Hello students and welcome to the Automobile Engine class. Myself Shanko host, Assistant Professor of Automobile Engineering Department at Dr. Sudhir Chandrasur Degree Engineering under the JIS. So students, in the previous few classes we start the discussion about the section B of the module number 5 and the topic was the fuel fed system in the diesel engine. So here in the first module we discuss about the introduction of the fuel fed system. Then we study about the requirement of the fuel injection system and the various components of this in the fuel injection system, and we study about the layout of the fuel feed injection system. Then in the second part we discuss about the various kinds of fuel injectors pump and the various types of fuel injectors. Now in the third part, today's the third part with this section B of the fifth module with the topic of the nozzle and the diesel fuel injection system. So students, let's start the today's class, which is the third part of this second section of the fifth module. The topic is nozzle. So basically the nozzle is the part of an injector through which the fuel is injected into the combustion chamber, and the nozzle spray the liquid fuel. The nozzle spray the liquid fuel, and the functions of the nozzles are the functions of the nozzles are one is atomization, second is distribution of fuel to the required area, number 3 is non impingement of the on the wall, and number 4 is no dribbling. So these are the main 4 functions of a nozzle which is fitted inside the fuel injectors. Here note that the fuel is striking on the wall. If the fuel is striking on the wall and it decomposes and produce the carbon deposit, so that this causes the smoky exhaust and the increases the fuel consumption. So to reduce the smoky exhaust and to reduce the fuel consumption, we need to maintain that the fuel when it is injected through the nozzle is not impingement on the wall, and just because of its not impingement on the wall, so no carbon is deposited on the wall. So as there is no carbon deposited on the cylinder wall, so it's obviously the smoky exhaust comes out or reduces, and the fuel consumption also decreases. And second is the high injection pressure allow the better dispersion and penetration into the combustion chamber. So high air density in the cylinder gives the high resistance to the traveler, the further causes dispersion. So these are the basic notes of this fuel when it is through from the nozzle. So basically the nozzles can be classified in the various ways. Those are single hole nozzle, multi-hole nozzle, pintle nozzle, Pintox nozzle. So these four are the types of these four are the various types of the nozzle. So students, let's start with the single hole type nozzle. This is the simplest. This is the most simplest type of nozzle. This nozzle is typically used in a open combustion chamber. Used in the open combustion chamber. The single hole nozzle requires a high injection pressure. The single hole nozzle requires a high injection of pressure. So this type of nozzle has a tendency. So this types of nozzle has a tendency to the dribbling. So the size of the hole is usually larger than the 0.2 millimeter. So its spray cone angle vary from 5 to the 15 degree 5 to the 15 degree. So the spray of this cone angle is usually narrow, and this gives a poor mixing unless the velocity is high. So this single hole nozzle is a basic types of nozzle where it has a single hole and the size of the hole is nearly larger than the 0.2 millimeter, and when the fuel is sprayed from this nozzle, it make an angle which is known as a spray cone angle. So this spray cone angle vary from 5 to 15 degree Celsius. As the cone of spray angle is will vary from 5 to 15 degrees Celsius, so that means it's spray in a usually non-narrow area. So that's why it is not the fuel is not properly mixed with the air. Compressed air is available in the combustion chamber. So for that reason we need a high velocity. We make a high velocity. We need to produce some high velocity to displace to spray inject the fuel through the nozzle. If I spray high velocity, then if we use a high velocity to spray the fuel from the nozzle, then it properly mixed with the compressed air inside the combustion chamber. Then we got proper. Then the air fuel mixture is get properly burned and properly power and actual power is comes out. So these are the basic pictures. Here is the basic pictures of the in single hole nozzle. So this cone is called as a spray cone angle. Now coming to the another type of nozzle which is called or known as the multi-hole nozzle. The single hole nozzle has a one number of nozzle. Here in case of multi-nozzle there are more than one nozzles are available. So that's why these kinds of nozzle is known as the multi-hole nozzle. So here the nozzle find in extensive uses. This types of nozzle means this multi-hole types nozzle extensive use finds in extensive use in case of the automobile. So this multi-hole nozzles typically vary 4 to 18 numbers of 4 to 88 numbers of hole. The greater number of hole as the greater number of hole is increased, as the greater numbers of hole is increased, it provides the better fuel distribution. As the better fuel distribution is generated, so power is created more, and because of the air and fuel is properly mixed together and then the mixture is ignited properly. And here the diameter of the hole vary from 0.2 millimeter to 0.35 millimeter, and it ensure the proper mixing of air and the fuel in the chamber. So as you can see in this picture, this is a picture of a multi-hole nozzle, and here just showing the three number of holes. So as there are three number of holes are there, so three from the three spray it create a angle that is called as a hole angle, and the diameter of the holes should vary from 0.2 millimeter to the 0.35 millimeter. So these are the multi-hole nozzle. Now coming to the next kind of nozzle, which is called as Pintle nozzle. Basically, the Pintle it has a thin end in form of a pin. So this Pintle nozzle have thin ends in the form of a pin, and the shape of the pin can be varied, and the shape of the pin can be varied. So that's why this nozzle is known as a Pintle nozzle. So it's hollow cylindrical jet. It's hollow cylindrical jet or the wide angle spray can be obtained. So it avoids the dribbling of fuel in the combustion chamber. So these Pintle nozzles basically used on the engine with the pre-combustion chambers, and some special turbulence chambers engines are available. So when we are talking about the pre-combustion chamber or some special kinds of turbulence available in the chamber, then we use basically this Pintle nozzle in the combustion chamber. So this nozzle basically is fitted with a pin-shaped shank. So that's why this nozzle is called the Pintle nozzle. So students, here in the picture you can find out that this is a Pintle nozzle. So from here it looks like a pin. Then it looks like a pin, and from here it spray inject the fuel into the combustion chamber, the pre-combustion chamber, or when we required some special kinds of turbulence chamber engine. Now coming to the another types of nozzle, which is known as the Pintle nozzle. So basically the Pintle type nozzle with an auxiliary hole drill in it. So when we are talking about the Pintle nozzle, so here this Pintle nozzle is basically modification nozzle of the Pintle nozzle. Here if we added an auxiliary hole which is drilled, and make the drill on the Pintle nozzle, then the nozzle is called as a Pintle nozzle. So this auxiliary hole injects fuel into the direction of upstream. So this auxiliary hole injects the fuel in a direction of the upstream and the direction of air before the main injection start. So it reduces the delay period due to the better heat transfer between the fuel and the air. So this Pintle nozzle results better in the cold starting performance. So student, when we are talking about the cold starting performance, for that time, for that area, that climatic area, if we use the Pintle type nozzle, so it will be easy to start the engine very quickly. So here is the picture of a Pintle nozzle, where this portion is the auxiliary hole. So this is the picture of the Pintle hole. Now, after knowing about the nozzle, now coming to the study of a diesel fuel injection system. So there are the various types of diesel fuel injection systems are available. In between them, the four are more common. The first one is the unit injection system. Second is individual pump injection system. Third one is distributor system. Fourth is common rail injection system. So students, let's start the discussion with the unit injection system. So the unit injection system. The unit, when you are talking about the unit injection system, there the fuel injectors, the fuel injector nozzle and the pump. The fuel injector nozzle and pump will be enclosed in one housing as a unit, enclosed in one housing as an unit, and this unit will be provided for each cylinder. So this unit will be provided for each cylinder. So there will be a low pressure pump. So there will be a low pressure pump which is operated by the rocker arm actuated as a plunger. So this here the amount of fuel injected into the cylinder, the amount of fuel which is injected into the cylinder is totally depends on the effective stroke of the plunger. So that's this injector nozzle and the low pressure pump are enclosed together. So students, when we are talking about the unit injection system, so basically the unit injection system consists of a single fuel injector, nozzle and the pump. Here these both, the pump and the nozzle, will enclose. Here the pump and the nozzle will enclosed in one housing as a unit. So this unit provided the each. So this unit is provided each and every cylinder. So there will be available a lower pressure pump operated. So there a lower pressure pump. So the pump is mainly maintained by the low pressure. So that's why this pressure pump is called known as a low pressure pump. So this low pressure pump is operated by the rocker arm. So when the rocker arm is actuates so the rocker arm is working, so it actuates the plunger. So when the plunger is actuated, so the pump is activated. So in this way the pump is actuated. So then if amount of fuel, so then after that some amount of fuel is directly inject into the cylinder, where it's depend on the effective stroke of the plunger. So students, here you can see this picture. This is a picture of the unit injector. So this is the engine area. Here this is nozzle holder. The nozzle is connected here. So from here inlet is connected in the pump. This is a pressure pump. So here is a pump and a nozzles are connected to one unit. So this is a picture of the basic picture of the unit injection system. Now coming to another types of injection system, which is called as an individual pump injection system. So in this type, each cylinder is provided with one pump and then one injector. That's why this system is called as an individual pump injector injection system. So this type differ. So basically this type is differ from the unit injector in that the pump and the injector are separated from each other. Here the injector, that means the injector is located on the cylinder while the pump is placed certainly placed side of the engine. So from the pump creates some pressure and stores the and sucks the fuel from the fuel tank after the filtration, and then it passes to the various fuel injector when it is in the injector, when the cylinders require need to inject the fuel. So in the proper cylinder, then a proper cylinder and a proper timing, the fuel is injected. So this pump, each pump may be physically placed, each pump physically placed on the cylinder, or it may be arranged in the cluster. The high pressure pump plunger is basically actuated by a cam, and it produces the fill pressure, and it produces the fill pressure where necessary to open the injector for fill pressure, which is necessary to open the injector valve at the correct time. So the quality of fuel, so that's why the quality of fuel injected is controlled by the effective stroke of the plunger. So students, here's the pictures of the individual pump fuel injection system. So there are used two types of system. Here each and the cylinders have provides in single injector, and single injector is connected with a single pump. So that's why this is called an individual pump. And there is another way pumps. That's because there is a two cylinders. So here we use only one pump, and this one pump is connected to these two cylinders. So there is basically two types of available individual pump fuel or injector. If we are talking about all the things individually, then the individual pump and the individual injectors are set for the fuel injection in the combustion chamber. The other one is each and every cylinder has an nozzle, and for an engine there was only a one pump which is fitted on the body of the side of the engine body. So these are the two types of the individual pump fuel system. Now coming to the another kinds of fuel system, which is called the distributor type system. So the pump, basically pump which pressurizes the fuel and also meters and times it. The fuel pump after metering the fuel pump after the metering is required. The quantity is required to the quantity of the fuel supply to a fuel supply to a rotating distributor to the correct time of supply to each cylinder. Correct time supply to each cylinder. Since there is one metering element each of the pump, and a uniform distribution is ensured. So basically the distributor type fuel injection Distributed type fuel injection system is one of the most common types of diesel injection system. Here the rotary distributed type of pump pressurized. Here the rotary type of distributed pump pressurizes and distributes the fuel for one of the cylinder. So one of the cylinder, the fuel from the fuel filters flow from the transfer pump to the distributed pump itself. Then the fuel is pressurized inside the distributed pump and the high pressure fuel is then directed to an injector at the appropriate cylinder. So the number, that's why the injector atomize the fuel for the proper combustion. Now here is the picture of the distributor types. So this is the fuel from the tank is coming here as the F1 is the filter 1 primary filter, then here is the secondary filter. This then the fuel line goes to the metering and the pressure pump. So here we have the single fuel pump. So this pressure pump provided the fuel to the distributor block. Here the distributor block are connected with the each, as there are four number of cylinders available. So that's why there are 4 injectors is showing us. So there are 4 ports. Out comes from the distributor block. So the distributor distributes the fuel and then the fuel in equal rate to maintain the equal amount and equal speed at the each and every cylinder with the help of the nozzle. So these are the basic pictures of the distributor type fuel injector. Now coming another type of fuel injector, which is called or known as the common rail system or CRDI. CRDI means the basically common rail diesel direct fuel injection. So is a directly fuel injection system which is used in case of diesel engine. Basically it features a high, features a very high pressure over 2000 bar or 2000 megapascal fuel rail which is feeding the solenoid valves as opposed to a low pressure fuel pump feeding unit injector. The third generation common rail, of the common rail diesel now features the piezoelectric injectors for increase the precision with the fuel pressure up to the 250 megapascal. So basically when we are talking about the common fuel system, it features a high pressure. It features a high pressure. High pressure means near to the 200 megapascal. This pressure, the fuel rail is feeding the solenoid valve. Fuel rail is feeding in the solenoid valve. So as it is opposed to the lower pressure, the fuel pump feeding the unit injector. So the third generation common rail diesel has a new features available which is known as a piezoelectric injector. So for this reason here we increase the fuel pressure from 200 megapascal to the 250 megapascal. So this high pressure injection delivers the power delivers the power and the fuel consumption benefit over the earlier lower pressure fuel injection. So by injecting the fuel as a larger number of smaller droplet, it giving a much higher ratio of surface area to the volume. So this provides improvement vaporization from the surface of the fuel droplet, and so more efficient combining of atmospheric oxygen and the vaporized fuel, delivering the more complete combustion. So here is the picture of the CRDI or common rail injection system. So here is the fuel tank available. So from the fuel tank, primarily filter is here. From the here, it comes to the secondary filter, and then it's go to the high pressure pump. It is called as a CP1. Then it passes through these two. One is the PCV at a low pressure. One is a high pressure to the directly to the common rail. So here when it comes to the common rail, then the high pressure of the fuel is entered into the injector. When the injector is fully closed, then the fuel is returned to this as a run to this line as a low pressure, and then it comes to the again to the fuel filter, and then it is stored into the fuel tank. Here is the basic pictures of the common rail injection system. So here is a control unit. There is automatically control units there, which is connected with the accelerator pedal, engine speed, crank speed, and the engine cam speed, and the other sensor and the rail pressure sensor also enter here. It out comes to the other actuators, to the PCV guards, and the sensor actuates the injector. So this is the basic pictures of the common rail injection system. So students, here in this today's section we discuss about the various kinds of nozzle, and we also discuss the various types of the diesel fuel injection system. So now in the next class we started with we will discuss about the governor. So still then, stay at home and stay safe. Thank you so much students.